12. Here are the problems in our fourth 6 weeks final. Problem 1. Which of the following is the equation of the unit circle? We went over this in class and it should be in your notes. These four equations happen to be those of the four major conic sections that should have been covered probably in an Algebra 2 course. Those four conic sections are a circle, ellipse, hyperbola, and a parabola. For answer choice A, we can easily solve for y by moving the negative y to the right side of the equation and the 1 to the left side. And that gives us y equals x squared minus 1. And when we graph this function, this is what we get, a parabola. Definitely not a circle, so we cross off answer A. For answer B, we solve for y by moving the x squared over to the other side of the equation. And so the equation becomes y squared equals 1 minus x squared. We solve for y by taking the square root of both sides of the equation, so y equals plus or minus the square root of quantity 1 minus x squared. And here is y equals plus or minus the square root of quantity 1 minus x squared graphed. It has to be entered as two separate functions, one for the plus and one for the minus. Here's the minus entered as f of 2 of x. And here it is graphed, both the bottom and the top half. Yes, this is a unit circle. Answer B. Answer C is an ellipse, and answer D a hyperbola. Problem 2. What is the cosecant of an angle that measures 5 pi over 6 radians? For this problem, we'll use the unit circle to help us out. Here is where we see 5 pi over 6 on a unit circle at 150 degrees. And since cosecant is related to sine, we'll evaluate the sine first, and the sine is opposite over hypotenuse, some old hippie. And the cosecant of theta is hypotenuse over opposite. And the unit circle, the hypotenuse is 1 and the opposite side 1/2. And 1 divided by 1/2 is 2. And this is where we see a cosecant of 2, answer D, which we circle as our correct answer. Problem 3. Joseph intended to draw an equilateral triangle using graph paper squares. This was the best he could do. To the nearest degree, what is the measure of angle A? To solve this problem, we'll use a trigonometric ratio. Which one will we use? We have an opposite to angle A, and that's 4 units, the height of the triangle. And what's the adjacent? It's the base. The adjacent is the base of the triangle divided by 2. So it's 5 divided by 2, or 2.5. So we can write the equation for the angle A. It's tangent A equals 4 divided by 2.5. And to get angle A by itself, we take the arctan, or tan minus 1, of 4 divided by 2.5 is equal to A, as in angle A. Now we go to our calculator and enter tan negative 1 of 4 over 2.5. And when we press enter, this is what we get, 1.0122. Is any of our answers 1.0122 degrees, or does the triangle, more importantly, look anything like it has an angle of 1 degree? No, it doesn't. We can go back to settings and change the mode from degrees to 2 degrees from radians, but if we multiply by 180 degrees over pi, we'll convert this to degrees, and this is what we get, just about 58 degrees. Now we go to answer C and circle it as our correct answer. Here's problem 4. Identify the 6 trigonometric ratios of angle M in the triangle MNP. Also, find the measure of angle M and angle N in degrees. When trying to remember the trigonometric ratios, especially when it has been a long time since I've used them, I think of this sentence: some old hippie caught another hippie tripping on acid. What this is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Right now, we know that the opposite side is 8 inches in length, or 8 in length, and that the adjacent side is 15 units in length. And since we have opposite and adjacent already, we can find the tangent. Opposite over adjacent is 8 over 15. And the cotangent is the reciprocal of the tangent, so cotangent M is 15 over 8. To get the other 4 ratios, we must find the unknown side. To use the Pythagorean theorem, we have the square root of 15 squared plus 8 squared, which is and it would be the square root of that. So it'll be the square root of 225 plus 64, and that would be the square root of 289, and the square root of 289 is 17, so our hypotenuse is 17 units. Now we can find the sine of M, which is 8 over 17. And the reciprocal of the sine is cosecant. The cosecant of m is 17 over 8. And since cosine is adjacent over hypotenuse, the cosine of m is 15 over 17. And the reciprocal of the cosine is secant, so the secant of m is 17 over 15. This is the first part of the problem complete, so we box in the answers, the 6 correct. Next we'll find angle m. To find angle m using our calculator, we can use any one of the 6 trigonometric ratios. The first thing I did, since the problem asks for the angles in degrees, I set the calculator to degrees. You can get there by going to Settings, Settings, General, and then changing probably radians to degrees. Next, press the trig button, highlighted in red, to get this menu, the trig menu. Since tangent is the first ratio we found, we'll use the arctan, or tan to the negative 1. We press enter, and this is what we get. In this mode, we're not given the angle to find the tangent, but we're given the tangent to find the angle. So inside parentheses, we place the tangent ratio, 8 divided by 15. Press enter. We get an angle for m of 28.073, rounded to 3 decimal places. So we'll label the degrees inside of angle m. And angle n is simply 90 degrees minus angle m, or 61.927 degrees. So we label angle n accordingly. Here we have all items as requested. All 8 items as requested. Problem 5. Which trigonometric ratio is the cotangent of theta? In order to find the cotangent, we'll look for the tangent first, and the tangent, that's tripping on acid, so it's opposite over adjacent. And the reciprocal function is that the cotangent of theta is adjacent over opposite. We have the adjacent, 12, and to find the opposite we take c squared minus b squared, so it will be the square root of 13 squared minus 12 squared, which equals the square root of 169 minus 144, which is the square root of 25. Which is our opposite side. The square root of 25 is 5, so that's our opposite side. So our cotangent of theta is 12 over 5, or 12 divided by 5, which is 2.4. And that's answer choice B, which we circle as correct. Problem 6. Convert 540 degrees into radians. To convert from degrees to radians, or from radians into degrees, we start with 180 degrees equals pi radians. So this gets us the relation of 1 degree is equal to pi radians over 180 degrees. So to solve this, we have 540 degrees times pi radians over 180 degrees. Degrees divided by degrees cancel to equal 1. And since 540 divided by 180 equals 3, our answer is 3 pi radians. And this is our boxed in answer. If you multiplied out pi, you got 9 point something radians. Try to leave angle answers in terms of pi when possible. Problem 7. Which of the following pairs of angles is coterminal? For this problem, it helps to look at our basic unit circle. Let's take a look at answer A. The angle pi goes from 0 to pi radians as shown in blue. That's 180 degrees. And the angle 2 pi is shown here in red, and that goes all the way to 360 degrees. And since they don't end in the same place, these angles are not coterminal, so we cross off answer A. Next, we'll try answer B. I'm leaving pi traced in blue from answer A, and that would be pi. Next, we'll try 540 degrees. 360 degrees is once around a circle, and then to get to 540, we have to go another 180 degrees. And these angles end in the same place, so where this green line segment is now. So these angles are coterminal. So we circle our correct answer, B. Problem 8. A car goes up a slant length of 1,000 feet as shown. If over that distance the car's elevation increases by 60 feet, what was the car's angle of inclination? The first thing to look at is this word, inclination. What is the angle of inclination? The angle of inclination is the angle that an incline makes with the ground level, so it's this angle inside the ramp. The sides we have are opposite sides of 60 feet, and the hypotenuse is 1,000 feet. So the equation we use is sine theta equals opposite over hypotenuse, and the opposite is 60, hypotenuse is 1,000. And to get this angle by itself, we have the arc sine of 6 over 100 equals theta. And here it is entered into the calculator. Press enter. We get about 3.4 degrees, which makes B our correct answer. Problem 9. A right triangle has an angle Q with a secant of 3. What is the cotangent of angle Q? The first thing I like to do is draw the triangle and work from there. First, let's consider that the secant of Q equals 3. And if the secant of Q is 3, it's a reciprocal ratio. The cosine of Q has to be 1 over 3, which would be, of course, a reciprocal of 3. And cosine is caught another hippie, so that would be adjacent. Cosine is adjacent over hypotenuse. So now we'll draw the right triangle. The adjacent side is 1, so we put that length first and label it here at the bottom. Next, we draw on the hypotenuse of 3 and label the corner of the triangle as Q. To get the cotangent, we need to get the opposite side, and that's going to be the square root of 9 squared minus 1 squared, which is the square root of 8, which is 2 times the square root of 2. And the cotangent of Q is the adjacent over opposite, which is 1 over 2 square root of 2. And this is where we see 1 over 2 square root of 2, answer C, which we circle as our correct answer. Problem 10. What is the angle of 2 degrees 30 minutes converted to decimal form? The key here is knowing how many degrees there are in 30 minutes. Let's think a little bit. There are 60 minutes in 1 degree. Therefore, we can multiply the 30 minutes times 1 over 60 to convert to degrees. Minutes over minutes cancel each other, so 30 divided by 60 equals 1/2 a degree, which equals 0.5 degrees. So therefore 2 degrees 30 minutes is 2.5 degrees, and that's the answer B. Problem 11. What is the angle that measures 13 pi over 6 radians converted to degrees? This problem brings us back to that relation we showed in an earlier problem converting the degrees into radians. And that's 180 degrees equals pi radians. This time, solving the equation for radians by dividing both sides of the equation by pi, we have 1 radian is equal to 180 degrees divided by pi. So in order to find the number of degrees there are in 13 pi over 6 radians, we need to multiply 13 pi over 6 radians by 180 degrees over pi radians. Pi radians over pi radians cancel to equal 1. To find our answer, we just multiply 13 by 180 divided by 6 as shown here in the calculator. So we write in our correct answer of 390 degrees, which we box in as correct. I saw a few students look at a unit circle and come up with an answer of 30 degrees. 390 degrees does not equal 30 degrees because 390 includes one entire rotation of a circle beyond 30 degrees. These two angles, 30 degrees and 390 degrees, however, are coterminal because they end in the same place, having the same terminal ray. Problem 12. Approximately how many degrees are there in 3 radians? This problem is very much like problem 11. For this one, we can use the relation between degrees and radians used in the last problem. And here it is in use. We have 3 radians times 180 degrees over pi radians. Radians over radians cancel each other to equal 1. In our calculator, we can multiply 3 times 180 divided by pi. We get very close to 172 degrees, so we circle C as our correct answer. But if you'd been thinking just a little, you would have not had to make any calculations. On the unit circle, we see that 180 equals pi radians. So 180 degrees equals approximately 3.14 radians. So the correct answer has to be a little less than 180 degrees, and 172 degrees is the only possibility that works. Problem 13, kind of a vanity problem. The students in Mr. G's class wanted to know his age. He agreed to tell them, but in the form of a trigonometry problem. He told them that his age is equal to the measure of the angle theta shown in the drawing. To the nearest whole year, how old is Mr. G? A student receiving credit must demonstrate shown work. Hint, if your answer is less than 40 years, you definitely made a mistake. Drawing not to scale. Yes, this problem is a true story that I've waited until creating this test to answer. I got a kick out of this. I had all kinds of answers. In my 6th period class, I had a couple write down the age of 36 years. I thought that was kind of funny because the problem itself says that if your answer is less than 40 years, you made a mistake. Also, how can I be 36 years old? I look a lot older than 36, and my kids are adults, or very close to being adults. I think they miscopied the answer and just weren't thinking. Anyway, the two sides of the triangle we have relative to theta are adjacent and hypotenuse. And the cosine theta is adjacent over hypotenuse. And in this case, the cosine of theta equals 14 over 25. And in order to get theta by itself, we use arc cosine or inverse cosine, and it's arc cosine of 14 over 25 equals theta. And here it is entered in our calculator. We get 0.976411. Is that really how old I am? Less than a year old? Of course, I'm not a baby. We need to change this to degrees from radians. We just have to multiply by 180 over pi to convert. And we get 55.9442, which by following instructions and rounding to the nearest whole year is 56 years, your correct answer. And one that I hope makes sense. Other answers I got 53 years for some reason. I saw 45 years, and one person got 72 years. Problem 14. John calculates that an angle with a tangent of 1 measures 0.785398 degrees. Where did John make a mistake? Let's try a couple things. First, let's take an arctangent of 1 to see how many degrees we get. And so entering arctan 1, I get 0.785398, just like John did. But for an angle with a tangent of 1, the opposite and adjacent sides have to be equal. In other words, that triangle needs to be a 45-45-90 or isosceles right triangle. We can either go back and try setting the calculator settings to degrees, or we can again multiply by 180 divided by pi like we've done here, and we end up with 45 degrees. And John got the wrong answer because the calculator was set to radians and not to degrees, so C is our correct answer. Problem 15. The coordinate pair -5, 2 is shown graphed below. This point is on the terminal side of angle theta. What is the tangent of angle theta? Tangent equals opposite over adjacent, or sine over cosine. So in the calculator I've entered 2 divided by -5. And pressing enter we get an answer of -2 over 5. But we can change the number to decimal by pressing Control then enter. We get -0.4 for an answer. So B is our correct answer. Problem 16. For the drawing of the arc shown in bold below, what is the closest to its arc length? For this problem, all we need is the arc length formula, and this is it. It's S equals R times theta. S is for the arc length, in this case what we're trying to find. R stands for the radius, in this case, the case of this problem, 6, as in 6 meters. And theta is for the angle, but the angle is in radians. In this case, the angle is already given in radians, and that's 2 pi over 3. We can just multiply the radius times the radians in the calculator, which is 6 times 2 pi over 3. And we get 12.5664, which is very close to 12.6, so we circle our answer A. Problem 17, our last problem. A guy wire from the top of the transmission tower at WJBC forms a 75-degree angle with the ground at a 55-foot distance from the base of the tower. About how tall is the tower? On this triangle problem, we have an adjacent side of 55 feet, and we want to know the opposite side, or height, of the tower. So the trigonometric ratio we'll use is that the tangent of 75 degrees equals h over 55. That's opposite over adjacent. The h stands for the height of the tower. And what was this 55 doing to the h sitting below it? It was dividing. So to solve for h, we need to multiply. So h equals 55 times the tangent of 75 degrees. What I'll do now is set the angle settings to degrees. And here is the settings window with the change made. And here's 55 times the tangent of 75 degrees entered. Press enter. We get 205.263, very close to answer C, which we circle as our correct answer. I hope this review of the fourth 6 weeks final has been helpful. This has been Precalculus 4th 6 weeks final 2012. Thanks for viewing.